Hey guys, this is Mr. Shower's video on molecular formulas. Now, this is a video that comes after empirical formulas and also percent composition. So those are two important videos that you really need to understand in order to do this. Now, this video is a very short video and it's very basic compared to the other two, but it's a very important step. Now, let's take a look. Okay, calculation of molecular formulas. Okay, the molecular formula is the actual formula of a molecular compound. So we're going to try to find that true formula of the substance we're trying to identify. Using the empirical formula, you can calculate the molecular formula. You're probably asking yourself, why are we using empirical formulas? Well, empirical formulas are data that can be derived from instrumentation in like quantitative analysis or another chemistry or other type of analysis equipment that give you the basic formula, which is a piece of what is actually in the sample that you're using. So now let's take a look at an example of an empirical formula, CHO. This is the lowest reduced formula. Now, like we mentioned before in the other video, the empirical formula, an empirical formula can have many molecular formulas. So just to show you, these substances right here, ethanoic acid, methanol, and glucose all have CHO, but they have different numbers. This is 242, this is 121, this is 612, 6. So they're all different formulas, but they have the same empirical formula. Okay, so these molecular formulas all are related to this empirical formula. And we want to make sure we calculate it properly. Okay, let's look at an example. Calculate the molecular formula of a compound whose molar mass is 60 grams per mole and empirical formula is CH4N. Now, step one is to calculate the mass of the empirical formula if it's not already given. Okay, in this case, we have C, and there's only one carbon, 4 H's, and 1 nitrogen. Now, when we look on the periodic table, we find their masses. Carbon has a mass of 12, hydrogen has a mass of 1, nitrogen has a mass of 14. So we multiply them all through, and we get 12, 4, and 14. Now, we add them up, and we get the sum of the total mass, which is 30.0 grams per mole. Okay, this is your empirical formula mass, which was not given in the problem. Now, step two is divide the molar mass by the empirical formula mass to calculate the ratio. So here we go. We take the molar mass, 60.0 grams per mole, divided by 30 grams per mole, and we get 2. This is our ratio. Now, we take that ratio, we multiply the formula subscripts by the ratio from step 2. So we have 1, 4, 1 times 2. So this is our empirical formula. Multiplying it by the ratio, we get C2H8N2. This gives us the molecular formula that we're looking for. Okay? Now, let's look at another example here. Molecular formula of diborane, okay, which is BH3. For example, experimentation shows the formula of mass of diborane is BH3 to be 27.67. What is the molecular formula of diborane? Okay, so what is the formula? Okay, this is the empirical formula. What is the molecular formula? Big question mark. Okay, so what you want to do first, step one, this is the problem here. Calculate the molar mass of BH3. So we go to the periodic table, we find one boron, and we add the 3 hydrogens to it, and we get 13.84 grams per mole. Now I want to calculate the ratio. So we divide the molecular formula mass and then the empirical formula mass, and we get 2. Okay? Then we multiply the 2 through the formula BH3, and we end up getting B2H6, which makes sense because the formula is called diborane, which is 2 B's. Okay, H6. So our ratio is 2 to 6, and that's it. Molecular formulas are pretty simple to calculate, nothing too complicated, and that's it. Thanks for watching.